Hey guys, this is a short video about some of the things regarding the polymer lab. Hey, stop it. Okay. All right, now, here's a couple of things regarding the polymer lab based on some of the observations I made on Thursday. There was some confusion. In particular, some folks just didn't know where to find some of the supplies, and so I'd like to show you that. So I'm going to take the camera, walk around the lab, and show you where things are so that you can find what you need to find. As is often the case, the thing that you need to measure out by weight, and the only thing in this particular lab would be urea, and you will find urea in the usual locations like the back corners where the balances are, right? So over there in that corner of the lab, there's a balance and a bottle of urea, and over in that corner of the lab, there's a balance and a bottle of urea, and in the middle of the U, there's a balance and a bottle of urea. Now, one thing about this particular balance, you notice it has a sheet of plastic on it. That happens to be a piece of plexiglass. I weigh out the styrene monomer here in this location, and so I use the plastic sheet to protect the balance. You can see drops of the styrene monomer sitting here from Thursday's lab. So you might find that I'm using this balance and you can't if I'm using it to measure out the styrene. So go find one of the other balances. Now let's walk around the lab and find some stuff. So one of the first things you're likely to do, because it does take a little bit of time before it sets up, is to make the urea formaldehyde one. As I say, you can measure out the urea at the balances. Just get the 2 grams that you need. But when it comes to the formaldehyde, you might remember this setup, right? Bottle of formaldehyde I have here, and I have attached to it an autopipetter, and the autopipetter is set at 3 mLs. Remember, I sent out an email to tell you that there is a correction to a typo for this procedure. So here's what I'd suggest you do. Under no circumstances do you use any glassware in this lab except for the test tube, right? One of these, where is it? There it is. One of these test tubes. And you use a small beaker for the nylon lab. Other than those 2 pieces of glassware, right? Small beaker, kind of like this. Whatever the smallest one is you happen to have. I happen to have a 20 ml one here, which is kind of cute. There's actually a 10 ml one, and that one's really cute. But when you measure out the urea, put it right into this test tube, bring the test tube up to here. All right, this red piece is only to protect it from oxygen. You put the test tube right up against here. I got to hold the camera with one hand, so I'm kind of limited right now, so I can't do it. But you pull up on the white part here, pull it up till this stop meets the lip and you can't go any further, and then make sure that you fully dispense once you have to get out into the test tube. Okay? So this is set up to measure the 3 mLs of formaldehyde directly into the test tube. Then find yourself a neoprene stopper. They are in this copper pot. Now where did I go? I'm about halfway down the inside of the U. So find yourself a stopper that would fit the test tube. It's a challenge to do this. Hey, I did it, right? You put that on and you give it a really good shake for a little while. It takes a few minutes for urea to dissolve in the formaldehyde. Once it does, hope you don't get dizzy. Once it does, you add a drop of HCl. And I've got these little dropper bottles of Con HCl. So just grab one of these when you're up here getting the formaldehyde. Share it with somebody else. I only have these 6. So when the time comes, you add your drop in, you shake it up a little bit further. Get near one of the sinks, turn on the cold water so that it's just flowing. You don't need it coming out real fast. But that's just to keep the formaldehyde urea resin from heating up too much. If it heats up too much, it gets brittle. and you only need to cool it off for a little bit until it settles down. Then what? Well, we've got a couple of other procedures to do for making polymers in this lab. And it really doesn't matter the order that you do the other three. So, if you look for styrene, let me tell you where I am. I am in near the back corner. This is hood, let's see what, 10, right? If that shows up on the video. This hood is normally empty during the Monday lab, but I should have this tray here and these little Dora the Explorer cups. No, wait, maybe that's not it anymore. Well, anyway, I have these little Dixie cups. They'll have the right amount of styrene in. Of course, it's empty right now because nobody's doing lab. But grab one of these cups. You'll need two in the long run, but do it one at a time. So grab a cup. Here is the catalyst for the styrene. You just add the prescribed number of drops to it. Stir it up with a wooden stick. I should have wooden sticks here on Monday when you guys come to lab. Stir it up with a wooden stick and pour it into the form. Now, where do you get the form? I have those in the middle of the U. You know what? I think I'm going to move them. But these are they, right? The little forms. So when you stir up the styrene, pour it right in here. Let it sit until when you tilt it, the stuff barely moves. When that happens, you're ready for the second batch. And if you're going to encase something in it, as someone did in one of the previous times this course ran, this happens to be a beer cap that's stuck in the polystyrene monomer, polystyrene cast, stuck for almost all eternity in there. So anyway, that's kind of what you do. And if you are encasing something that you actually do want to keep, you got to let the stuff set and fully cure. That takes a couple of days. When you're done, well, basically when you come back next week to do your checkout, you'll take your cup with whatever's in it, you turn it upside down, you smack it on the tabletop, and the cast will come out of the container. Let's see, what else do you have to do? There are two other parts of this lab. One of them is the polyurethane, to have some fun with that. Here I am, I'm actually on the opposite side of the lab from where the styrene is located. And over here you'll find actually two polyurethanes, because I found out I had some of the flexible stuff. You're welcome to try it if you want to. Notice the flexible one has a pink label. The rigid polyurethane has a white label. So make sure you grab the one that you think you're grabbing. If you want to play with the flexible, wonderful. If you want to play with the rigid one, actually the rigid one is what's in the procedure. I don't know how long the flexible one will last. Perhaps not everybody will get a chance even if you want to. The procedure says to take one of these paper cups. You see they're all just stacked up right here. You take one of these paper cups and then you measure out A and B. This one's not labeled. There it is. It's labeled B. And you measure out, and I wrote it on the glass up here. It's 1 part A and 1 part B, and you stir it up really well with one of these wooden sticks. The procedure says to add half as much of one of the parts as you do the other. And it says to add about a half a centimeter. Half a centimeter is about 1/4 of an inch for those of you who are Occidental. And, well, actually, that's not Occidental. Because Europe went metric anyway. They're part of the Occident. And, but if you're very American, as I am, and you think in terms of inches and not metric, go for about 1/4 of an inch. So about 1/4 of an inch of part A, about 1/4 of an inch of part B. And that's so it completely covers the bottom, not just a small dot of the stuff. And then grab yourself a wooden stick, and with the wooden stick, stir, 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 until you're sure that it's all mixed up. And once it's all mixed up, just set it down and let it go. The same thing is true of the flexible one. Now, the flexible one, though, is meant to be used in a different ratio. You again have a container that's labeled A and a container that's labeled B. But in this case, and again, I wrote it up here on the glass. So it's 1 part A, but 3 parts B. And you can guesstimate that if you're good at guesstimating. Just try to guesstimate it. And then the same thing, grab a wooden stick, stir it up as much as you can. Make sure it goes into one of these paper cups. And then once you get it stirred up well and it's mixed to a homogeneous mixture, just let it sit until it does its thing. And what kind of a thing will it do? I've got a couple samples over here that you can see, and I'll show them to you quickly on video, but doing it for yourself is really good. If you put in a little too much, this is what will happen. It'll overflow the container and end up all over the place. But yeah, it's pretty neat stuff. The flexible one comes out like this. Yeah, I was able to actually remove it from the paper cup, but the flexible one is kind of neat. It's nice to see that there's a complete difference. You know, you squeeze this one, nothing happens. This one here, kind of like a muffin. Now, one year I heard reports that these were painted and left laying in lower manger, so people thought they were muffins, and that's all I'll say. And let's see, what's the last one? Oh, here's one that I just made up a few minutes ago. Once again, it's come out of the container, kind of cool that way. And there's the wooden stick that I left in it. I'm thinking about putting a straw in here, and so kind of looks like a root beer float that got out of hand. All right, last one. You've got nylon to make. Again, you're taking the smallest beaker that you happen to have. Notice where I am. I'm in the back corner of the lab, right by the sink. That's opposite the door, okay? Here you will find 2 glass bottles that say Nylon Prep Solution A, Sabasawheel Chloride, same thing here. And next to them you will find a pipette each. So bring your small beaker back here. Measure out 3 mLs of solution A. And remember, this is dissolved in methylene chloride, so it's more dense than water. So measure out your 3 mLs, put it into the small beaker, and then when you turn over to this side, you'll notice that there are 2 plastic bottles, and they say, well, this one says 1,6-hexane diamine. This one says diaminohexane, different labels. But the important thing is, notice they are in plastic bottles and they have their own pipettes. Now this is where you have to be careful. You take the pipette, measure out what you're supposed to measure out according to the procedure, and then carefully put it into the beaker that already contains solution A. All right, and you put it in carefully. You put it in, if you squirt it in, it'll mix. If you put it in too fast, it'll mix. If you put it in nice and slow, then it just runs out on top of solution A and sits there and waits for you. And again, as I told you in class, in lecture, at the interface where the 2 layers meet, you should see it gets cloudy. And if you're super careful with a pair of tweezers or a paper clip, you can grab a hold of that interface and pull it up, and you'll start making a rope with it. That's really, really cool when it happens. If you're super careful, you can start wrapping the rope around a test tube and see how much you can pull out in one shot like that. One other thing I should tell you, and I probably should have mentioned this first, but notice how I put down a layer of paper here on the hood, and I did over there where I have the other stuff. I want you to do the same thing. So when you first come to lab on Monday, notice that up here in the front of the U, I have a couple of plastic bags. They've got newspapers in them. Just take a section of the newspaper and open it up and lay it down on the floor of the hood. All right, just lay it down right in here. That way, when you're all done today, you can just roll it right up together inside the newspaper and put it in the trash. Okay? And that'll work out well. Let's see, anything else I need to tell you? I guess not. I think that's probably about all I really need to say. So I think I'm going to say that's it. I hope you have a fun time with this lab. Some folks on Thursday had a lot of fun with it, and do your best. I should also remind you that next week when you come in, it will be your last time in this lab, and you will have to do a quick checkout, make sure your glassware is cleaned up, make sure you got what you're supposed to have, and you, perhaps more importantly than anything else, need to turn in your notebooks. I will collect them then, try to grade them, and account for what's missing as far as grades go for this course. And I think that's it. Have a wonderful afternoon, evening, morning, whenever it is you happen to be watching this. Ta-ta.